Hello everyone. Today I'm going to walk through knowledge graph based movie recommendation system. So in this project, we are leveraging knowledge graphs, generative LLMs, and also various prompt patterns to build a sophisticated movie recommendation engine. So myself, Krishnakant, my teammate is Bhargavi, and we have developed this project. Uh, so coming to the introduction, as I said, we want to build a very sophisticated and semantically capable knowledge graph based movie recommender system, which has capability to understand the semantics and also of relation and have capability to understand the each entities and also their relationship to recommend very relevant and also very useful recommendations to the users based on their inputs. So for this purpose, for me, it was needed to generate a cipher query using a text. So when a user gives a text like recommend some movies which has some IMDb ratings of 7 or something, so the model LLM model should able to convert that text into a cipher query, which is why I have fine-tuned a Llama 3 model to generate cipher queries. So, so this is the fine-tuning Llama 3 model notebook. So for this, I have used Llama 3 base model using Unsloth for faster training process. And I have fine-tuned this on a text to cipher data set, which is available in Hugging Face. And this data has some context like user query. So I can see here, given an input question. Yeah, so we in this query, we generally use the examples of question, also the cipher. So this is nothing but the cipher query and schema of the graph database. So we use this prompt to fine tune a Llama 3 model. Uh, After fine tuning, I have saved this model to the Hugging Face under this repository, and you can find it in the Hugging Face as well. So coming to the architecture, so I have three different models saved in Hugging Face. One is 16-bit model, 4-bit model, and also LoRa model. You can find it over the Hugging Face. And my friend Bhargavi will walk over the architecture diagram.
Yeah, coming to the architecture, the initial step would be first taking the data as an input. So our data here is a movie data set, which is actually a tabular data, which contains a lot of can you open the data? So this has a lot of columns like plot, what the genre is, and what is the entire plot of a movie, and then what the directors are. And also it has information about titles, or on what language it is released in, and etc. And coming to the architecture, like I said, the entire tabular data is first converted to a cipher Neo4j database, which uses a cipher query language, just like SQL queries. So we convert this into graph schema, graph databases using a graph schema, so that we tell the so that it's useful for us later to follow this schema to generate cipher queries. And this Neo4j is triggered in all of the approaches we use. So whenever an user gives an input to the Streamlit application, the input is just a natural language. The user can just say, I recommend a movie which is over 7 rating IMDb. Or it can also, the user can also say, recommend a movie which is of a romantic genre, etc. So we use three different agents to process the input given by the user. In the first approach, which is a simple RAG agent, when a user gives an input as a natural language, we convert that to a cipher query and then use that cipher query to extract a movie from the Neo4j database and then and use large language model to enhance the result so that it's just an text which gives back to the streamlet. Similarly, in the second approach, we use an embedding based agent where the user query is converted to an embedding and then used to find is just done does a similarity search of embeddings of a user input to the graph database and then extracts recommended movies and then gives as an output. And in the third approach, we used entity extraction based agent. Entity extraction happens when a user gives an input. Let's say if a user says, I want this movie based on this genre and this cast, and we take all of these entities from the user so that we map them with the schema which we already generated for creating a table data to Neo4j and extract recommended movies for the user and again process to the LLM. So all of these outputs, which when given LLM gives an enhanced human readable output so that it again gives back to the streamlet where the user can actually see what the recommended movie is from the entire system. So this is all the overall flow. Coming to the tech stack, like I've mentioned, we have used Neo4j for graph databases and also embedding searches from the database and also Streamlit for user interface to give input and give out the output. And we used large language models to interact with Neo4j database and we have done a lot of prompt engineering techniques in a lot of our internal components. And for local model capabilities, we used Llama because using open source is relatively very expensive when processing our queries. And the coding is all done in Python, and the Cypher queries are used for Neo4j database. And all the required usernames and password are securely stored in .env files while deploying.
Now I'll quickly go over the complete process. So I will show the all the implemented agents which my friend just spoke about. So coming to the workflow, so this is how our data set looks like, which has titles, languages, which has multiple languages, and award information for the movie, IMDb ratings, directors, cast, and also genre information. And tagline is nothing but a small story about the complete movie. So it's like a movie information. So first we load Neo4j graph database using given username, password, and also URIs. So once we have the graph database, this is how the database schema looks like. And if I can show here, so this is how we modeled our graph database. So we have a movie node which has properties like title, award, ID, and also tagline and IMDb ratings. And the movie is connected with a person which has director and also the cast who acted in the movie. And similarly, we have a genre node which has the genre information and it is connected with the movie node. Similarly, we have language node which has language information and it was connected with the movie with the relationship of was released in. So this is how our node, graph database looks like. Coming to the first simple agent. Yeah, so the first simple agent generally takes an user input and convert it into a cipher query based on given graph database schema and also the user question. So in this, we just pass like we just ask a question like who was the cast of the movie Roadhouse? So for this question, we can see that the graph database response is actor so and so and actor so and so because this movie has multiple actors for the same movie Red House. So, and here you can see the improved responses. The cost for Roadhouse are so and so cost. Uh, right? And similarly, if we ask some question like what are the most common genres for the movies who got awards, right? So this is how. So for this question, what are the most common genres? So this is how Graph database responded, and based on this response, we improved this response and generated like this, which is very readable for the human. So we can see that action-based movies have 18 awards, adventure has 10 awards, so and so. So coming to the Cipher query QA chain, which is also a simple query agent, but this is a method built in LangChain. So this is an inbuilt method which we just pass the graph database and also the LLM. Uh, that's all. If we ask a question to the this query chain, it will generate the response. So if I ask the same question like who was the cost for the movie so and so, and here is the response of the model. Similarly, most common genres for the movies who got awards. Action and adventures are the most common genres for the movies that have received awards, right? Yeah, so then coming to the second agent, which is an embedding based agent. So we generally, firstly, we created an vector index on the same graph database based on the tagline embeddings. So first, when we get a question like, can you recommend some top genre movies which has awards? So first we embed this question, so we generate the question embedding and we do the vector search uh, uh, to get the top three results. And once we get the results, we enhance that based on the above information. We summarize and format it in more better way, which is more understandable and readable to the user. So for a given question like recommend some top genre movies which has more awards. So here are the response by the model. So drama, which has 5 movies with a total of 17 awards, action 4 movies with a total of 13 awards. So this is based on the embeddings approach, like mentioned here. So yeah. Then coming to our last agent, which is the robust agent, because so if a user asks a question which has lot of entries like entities like cast information, award information, and also director information, all such entities, right? So then the model cannot generate a very quality cipher query. So to overcome this, we first look at the user query, then we break down the user input and extract the relevant user entities, and we then map with the schema. So to validate all the extracted entities are available in the graph schema. So once we have that, we build the quality cipher query and we again validate the generated query and the relation with the schema. And for a query like who was the cost for the movie Roadhouse and does the movie got any awards? So here we can see that the model able to generate a quality cipher query, and here are the responses. And based on the fetched results, we improved that result to show it as a readable format. Similarly, can you recommend some top movies question which has more awards? We can see the model was able to respond with some results. So this was a robust approach which can overcome any complex question, and have personally tested with many different questions, and the model was performing really good. And yeah, here maybe this is the last example. So if I ask like recommend 3 movies which has at least one award, and it should be in the English language. So we have 3 entities like movie entity, award entity, and also language entity. And model able to generate the relevant cipher query, which can able to generate a result over the graph database. And these are the 3 ways of how we generated results over the question user question, and also improved the uh, querying and also retrieving information using advanced techniques like embedding based and also entity based approaches. And then coming to the model evaluations, so here the main challenge of our project is generating cipher queries using text, right? So the main so The evaluation system in our project is validating the quality of cipher query. So, so my friend will talk over the evaluation metrics.
Yeah, the focus is evaluating the cipher queries based on the schema we already have, because if the extraction of the movie from the graph database is not correct, and the LLM can also not help in generating any good recommendations. So the main focus is on cipher query generation and also extracting movie from the graph database. So we used a model, our fine-tuned large language model, which we fine-tuned Llama and then pushed it to the Hugging Face. We use that for for generating queries from the user questions. So let's say when a user asks any questions, I want this kind of movie, we then generate cipher queries from that movie based on the entities they ask. So we map this with our existing model generated cipher query, so that we know actually we are generating the correct movie. This is how we validate the correctness. Um, and we don't just do a string to string match, because it's really important for us to understand how much of an query generated by a large language model is correct. So string to string match doesn't work. So we do a similarity search between two different cipher queries. And with a high threshold, we got good results, um, which is around 90% correctness.
So here are the descriptive statistics of the similarity scores. So we generally compare the similarity score between the cipher, which is the actual cipher query, and the model generated cipher query. So once we have the scores here, right? So we check the descriptive statistics, and we have selected a threshold of 80% to 85% to validate whether this query is true or not. So if any query greater than threshold, like if the similarity score between the generated cipher query and the actual cipher query is greater than 0.85 threshold, we mark that as a match. So by comparing this, the accuracy of the quality of cipher query generated was like 90%. And similarly, our results also very good, and we personally checked all the three agents with the models. And yeah, it was a great project, and I have mentioned everything over here. Coming to the installation guidelines. J- So So we have a detailed document with everything we mentioned. We have created a complete outline, and also went in detail about everything. And coming to the installation steps, you just need to clone this repository and create a .env file with creating a Neo4j database, and just put in all this information in the .env file. And finally, you just need to pull two models from Llama just for running from locally. One is All Mini LM, which is embedding model, and the text to cipher demo model. So once you have that, we also have Streamlit app. No, you can do the requirements installation by using pip install requirements.txt. We already updated our requirements text. We have the app, so you can simply do the streamlit run app.py, and you can load the Streamlit app. Thank you so much.